Alright, so welcome to a new episode of the Plumbers of Data Science podcast. This time with video. I thought, let's try something new. Usually I record in my car, but now I'm doing some Q&A sessions, so I think it's a bit more interesting to actually see the questions and to actually see me. And what I can do here is I can go to my desktop and I can show you stuff that I find interesting and that fits to your question. If you have some comments and I'm getting something wrong or you'd like to add something, please use the comment section below if you're on YouTube and add your comment there. If you're not on YouTube, you can write me on Twitter, #plumbers of data science. You can go to my LinkedIn, add a new question, add some remarks. I'm going to put this in the next video. And also, if you're not subscribed, if you're on YouTube and you're not subscribed, go to the subscribe button below and subscribe and hit the bell so you get notified of new uploads from me. And yeah, always hit the like button. Let people know this is a good stream and that you're supporting. And at some point, if you have something to add and you think I'm missing something, again, please use the comment section below. So I got a lot of questions already from you. I think it was over 100 questions that I counted, and I think were interesting to get answered for beginner data scientists, for beginner data engineers. Yeah, it's 5 a.m. Right now it's about 6 a.m. I'm having a tea. And just let's go over some questions. Okay. So David asks, what even is data science versus data analysis? What's a junior data scientist versus a senior data analyst? Okay, so I'm not really sure about junior data scientists and senior data analysts, but in general, the distinction I am always taking between a data scientist and a data analyst is that the data analyst is more is not so flexible and it's hard to explain. So the data analyst versus the data scientist, it's when you think about the problems that he solves. The data analyst is more like, here are the tools, here's the data, here's the question that I want to have asked. And so the analyst, like a business analyst, business data analyst, BI analyst, he has the data from SAP and so on, and he's having that. He's having the tools like Tableau and so on, and then he needs to answer a question. And so he's relatively fixed in what he can do. When you now look at a data scientist, it's more like, here's the question, I need this problem answered, this is the question, and now tell me, what data do you need, what tools do you need, what tools can you use. So you're more free, and yeah, it's it's more an open question, and the business guy needs to be told what data do you need, what data do I need collected from a data scientist, or does the data scientist needs to have collected, and then analyze with some tools. Doesn't need to be a fixed. So it's, yeah. Next one from Kate. Kate asks, what should an aspiring data scientist do if they can't find an internship or job to get started? Assuming they have done some coursework and are ready to be recruited. Well, one thing that I'm for a long time arguing is that you need to go out and put yourself out there. I mean, Kate is doing this as well. You need to get out there. You need to show what you can. So take part, for instance, in Kaggle competitions, or do some other stuff, something you may come up with yourself. Analyze data, ask some questions, and try to figure out how to use them with data science, how to solve them with data science, and then document the whole journey. Get yourself a blog on Medium. It costs nothing. You can document this there. Go on GitHub for your source code and so on, and document it, and then try to build a reputation through that and through social media. And when you then apply to a job, go out there and advertise this. So in your CV, help people find the stuff you've done, and then start with an internship. Try to find an internship and build your actual work reputation up. But the first thing is, after you have learned stuff, go out and just apply what you have learned, and try to show people that you're applying to where you're applying jobs to jobs, that this is something that you're the right guy for that. Next question. Oh, that's a big one. How are the roles data scientist and data engineer defined in a large enterprise versus a small venture? Okay, this is actually a big question. I think there are multiple questions here. The first question, part of the question, how are the roles data scientist and data engineer defined? So very loosely, I would define it that the data scientist is the guy who analyzes stuff. Thanks, Ankit, by the way, for the question. Data scientist is the guy who analyzes stuff, and the data engineer makes sure or supplies him with the data. He is building up the infrastructure. He is working all the way to get the data, make the data available for the data scientist, make the tools available for the data scientist on the platform that he is using, and then the data scientist is analyzing the data, creating the insight, and then the data engineer is again responsible for taking the insight and somehow deploying that to the customer, or showing that to the customer, to the one who asked the question. Let's say if you're on a platform, the data scientist is creating the insight, the data engineer is making sure the insight is getting to a front end where the data is then displayed. So this is data engineer, data scientist. Now the second part is how it is defined in a large versus a small venture. That's the part where people often come up to me and say, well, okay, I'm doing both. It's the distinction between data engineer and data scientist is not that big. Look at me, I'm doing both. And yes, in a smaller company, you're most likely to do a lot of both. That you look into how to get the data, how to collect the data, store it, and then analyze it. So because you're more flexible and you don't have the staff to do all that. In a large enterprise, however, it's more distinct. It's more you have let's say bigger platforms, you have more use cases, you have more stuff to do on the platform, so you need to separate this, and you have a data engineer and you have a data scientist. Because let's look at this way. The data scientist is good at analyzing data, is good at machine learning, is good at creating insight. And why waste the potential from him to create insight with other work that he's not the absolute specialist for? So have a specialist. Big companies usually have specialist data engineering, specialist data scientists. I would say that's a good that's a good way of looking at it. And smaller, you're more a generalist. Second part of the question, what is better, to be a generalist or a specialist, especially when you're talking about data engineering? Well, in general, the data scientist is more a specialist and the data engineer is more a generalist, because you need to know a lot of stuff. You need to know Linux, you need to know networking, you need to know how firewalls work, you need to know the tools that are used, you need to know how databases work, how front ends are created, technologies, and so on. So it's a more a generalist role that also needs coding, but it's more a broad spectrum of topics, and you can, let's say you're very good at programming Spark and creating databases and so on, but it's not that you go really down and know every aspect of a SQL database and how to manage a SQL database from the ground up, and you're more you're more on a level how to actually use that to create value for the data scientist, so that he can use it. Of course, at some point you need to, if there are problems, you need to go down into everything and look at everything. But it's more a generalist role and not like a data scientist who is going deep into one topic of analyzing data and maybe deep into a technique like deep learning and going deeper and deeper and deeper into a topic. Next question from Mohammed. Where can I find some data science related projects, and what is the difference between data science and big data? Okay, so where you can find data science related projects, that's not really that simple. One good location is always Kaggle. taking part in a Kaggle competition, but this is partly there are some very difficult problems there. I need to look that up, and I need to get into that later. What's the difference between data science and big data? There's actually let's say big data is a part of data science. It's the motor of a modern data platform, and because of this, it's more a tool used in data science, and yeah, it's let's say it's a tool, a modern data platform tool to power data science, make it possible to analyze big amounts of data and quickly in parallel. And yeah, this is, let's say, it's not like the difference, it's a part of data science, of a data science platform. Okay. Then there's Dmitry. Dmitry has many questions posted. Let me just get into this. Best strategies for moving data infrastructure to the cloud, and by how much this move could potentially reduce cost of ownership. Now, moving infrastructure to the cloud, let's say you have a on-premise installation, what you can do is you have your installation on-premise, and you build up your cloud infrastructure in parallel. And then at some point you start switching and sending data. Instead of sending data to your on-premise, you're sending data to your cloud. And so the cloud is building up data. And at some point this on-premise will have no new traffic, will all have old traffic. And then you're trying to make to send the data slowly to the new platform. And what usually happens is that the data that you have displayed to customers, or for insight, that has the insight, that is relatively small. So you're shuffling the data from the, or you're moving the data from the front end data, the visualization data, from the old front end to the new front end very quickly, the historic data, and then all the other data that is there used in data science, maybe terabytes of data. You can either upload this, or for instance AWS has a service where they are sending you like a container, and a small container that you can put into your network, and where you can upload your data. And what they do then is you send the snowball, I think that's called snowball, and then you send the snowball back over mail to AWS, and they import your data, and then it's there, or just upload it. But that might take some time. Regarding cost savings, it's not really super cheap. The cloud is expensive. It's not that cheap. If you create a one-to-one setup, so you're using the exact same tools on the cloud or on premise, I think there is not really a cost saving. Where you can save cost is when you use tools from the specific platform. So instead of setting up a key value store, or let's say instead of setting up HBase to store data, you're using S3. So you're saving saving money on setting up and maintaining HDFS. Yeah, so it's more the overhead costs that you can save by saving manpower to maintain stuff or saving licenses. But then what you have also need to keep in mind is that you're then a vendor lock. You have a vendor lock in, so you cannot change. You cannot change between cloud platforms because you're vendor locked into, let's say, a thing like DynamoDB. It's always a trade-off, but yeah, I think saving money isn't really there. You can save some money if you're, let's say you have a startup and you know you get a lot of data and you just get the data and put it in S3, forget everything Hadoop, Spark, Kafka. A simple thing. You have a API. That API posts into Kinesis, and from Kinesis it gets into a S3 bucket by use of a Lambda function. It's not super expensive, and you can do a lot of it. But if you're going to set up a huge data platform with Hadoop, Spark, Kafka, everything managed by you on top of EC2 instances, this gets expensive. So saving money depends exactly on what you're doing. Question 3. Here, as soon as you mention the buzzword big data, how big is your data? Cannot really tell you how much data I'm handling on a day-to-day basis. If seriously, what data volume and velocity should be generated by a business so the engineers working there could wisely call themselves big data engineers? Man, that's always the thing. So I think there's not a distinct line between big data and not big data. It totally depends on your use case. When you look at the four V's, volume, velocity, veracity, and variety, it's not that there's a 100% line of there you have big data, there you don't have big data. It's more like figuring out where you're going with your platform, where you're going with your service that you're offering, and does that still work with traditional tools like SQL databases and so on? And are you analyzing data in a way that you're analyzing huge data sets? Huge data sets in the means that it does not longer work with ETL jobs, that where you extract all the data, then munch it or analyze it, and yeah, like if you think about a SQL database, you need to make a select statement over a billion of rows or multiple billions of rows, and then make a huge analysis of that, or make a statement and then transfer the data out of the SQL database somewhere, make an analysis of all that data, and then sending the data back. You will get to a point where that no longer makes sense, and veracity and variety is not the most important here. It's always volume and speed. Let's say the data comes very fast, and also how you analyze it. Are you analyzing only small chunks of data, or are you also looking into analyzing a big volume of data, and then you need a parallelized, I'm always having problems with this word, a parallelized infrastructure. I've done a podcast recently about this. Is this one, September 10th, why distributed processing is super important. This, check out this podcast. There I'm talking a lot about why you need distributed processing, what exactly that means for a platform, and that is always also a part of big data. When to use big data and why not. Okay, so where was I? This one. Okay. Wisely call themselves big data engineers. I mean, the most important thing is that you don't use big data tools if you don't need them. If you don't need them and use them, this will get you into a lot of trouble. It's complicated, it's expensive, and if you don't need it, it's overkill. Super important to not fall into the trap of being cool, being big data. Don't do it. Figure out if stuff still works with traditional systems, and figure out the growth of your platform so you don't get stalled if, let's say, your startup explodes and you get users in the thousands or tens of thousands a day. And the fourth question I'd like to answer later. Soft skills and hard skills of a data scientist. Maybe I'm planning some sessions with a data scientist friend of mine, so I think for those questions I will get a specialist in here with me. Question 5: how big a data science or data engineering team should be in the company, generating up to 10 gigabytes, 100 gigabytes, a terabyte of data a day? And what is the best structure for data warehouse data engineering team to deliver result efficiently? I'd say you would be surprised. It's difficult to answer without getting into some exact details, because obviously I need to hold some information back here, because I'm not allowed to share my actual experience in the company I'm working right now. I'd say you'd be surprised how many people you need, or actually you don't need. You can do a lot of damage with only a few people, only a few good data engineers. It depends on the platform you're using, and it depends on what kind of data you're getting. If you're getting, let's say, if you have a problem that is very I don't know if serializable is the right word. If you have a problem, if you get data from, let's say you have a few interfaces, and the data you're getting is always the same form, it's the same task. You're getting log data from some systems, or you're delivering machines to customers, and those machines are always looking the same, and they are coming always over the same paths. They're using the same APIs. They're getting handled, and they're getting put into a workflow, into a storage the same way. You don't need a lot of people. It doesn't actually make a difference if you're getting a megabyte a day or if you're getting a terabyte a day. If the pipeline is created, and if the pipeline is used, and it's a scalable pipeline, the actual operation of how much data is generated a day doesn't really matter. It's setting up a data engineering team that can set up a platform and that can manage the pipelines and set up new pipelines and supply the data engineer, the data scientists, the data science team, the analyzers, the data science team with data. You don't really need a lot of people for that. You'd be surprised how few people you need. Was there more? Yeah. So okay, let's write this down. The data scientist life cycle. Data scientist life cycle, and what was the other? Hard and soft skills. Those questions I will take with me, and I will, once I get my buddy on the line, he can then answer these questions. Okay, Zach asks, where's the best place outside of work for you to practice handling huge data sets? You don't. There's no real place outside of work, outside of a project, outside of a startup to handle huge data sets. The thing you can do, and this is this fits to Dimitri's question that I've answered previously. You don't need to handle big data sets to learn the tools. You don't need to it doesn't make a difference if it's a megabyte or a terabyte data that is going through a pipeline that you have set up. That doesn't matter. So if you create a pipeline, Kafka, Spark, into something like S3 or Kinesis Lambda S3, or analyze some data with Spark from S3, it doesn't really matter if you're learning with a small data set or a larger data set. The only difference between small and large data sets is that in terms of analytics, it takes longer to analyze them, and in terms of a pipeline, you have more load on the systems that are providing the pipeline. You have more load in Kafka. You have more load in Spark because of your uploading data from Spark into Hadoop or into S3. So the actual size of the data that you're handling is not that really important, because if you try it at home and the pipelines work at home or work in test, when you set up the systems, when you actually set up the systems and they are managed and they are working on strong hardware, they are going to work as well. So there's not really a need. Okay, I think there were some questions for the first session. Yeah. Tomorrow I have set up 4 more sections of questions here, but we're already 40 minutes in, and I think it's okay for today. Let's meet again tomorrow. I'm going to put this up on my YouTube now. I'm doing some light editing because sometimes some ahs and ahs and and scratches need to be edited out. Yeah. Okay. That's it for now. See you tomorrow. And if you like this one, hit the like button. And if you haven't already subscribe and maybe and click on that bell. Yeah. If I'm wrong somewhere, add a comment below, and yeah. See you tomorrow. Bye bye.